Okay, I'm gonna do a quick test here to see if I can get Alpaca set up. Alpaca is a library for evaluating large language models and comparing them to each other. So if you are training a large language model, or if you're doing a fine tune and you just want to confirm that you didn't somehow lose some performance, you can use Alpaca to evaluate your model. So here's the little GitHub repo for it. And I'm just going to try to work through the instructions and see if I can get this to work. So I'm going to start by installing it, which could be the most risky part of the whole thing. So let's see how this goes. Oops. Before I do that, let me just, I just created a PyEnv environment. So now we can install this in our PyEnv environment that's dedicated to this project. And we'll see how. Okay, so I got it installed and I got my OpenAI API key set up. So now we can try to experiment a little bit, and let's just say Alpaca eval, see what options it gives us. Okay, well that was cool. So I ran Alpaca eval, that took a minute or two to run. And right here we have a leaderboard that got computed. So that's pretty cool. I was not expecting that to happen. We can interpret it a little bit. We have each model that's being compared. I think this gets compared. I'm not sure what this is getting compared against right now. I guess a 50-50 win rate against GPT-4 1106. So that is what everything's getting compared against. You can see GPT-4.0 is a little better. And you can see some of these other models here are a little worse. So that's super cool. So there are a couple things we can experiment with. GPT just released a new model today. OpenAI just released a new model today. They released their GPT 4.0 mini. So we can try to put that into the leaderboard and see how this works. So let's see how that goes. The way that works, and we will find out here, is we just are going to go into our repo. And we're going to create a new model config. So let's create one for GPT 4.0 mini. You can see they have a bunch of other GPTs here, so ours should fit right in. Even there's that one. Cool, so we create a new folder for that. One of these other, so we're going to create a new file, a configs.yaml for that. And we're just going to grab one of the similar ones, and we'll call this GPT 4.0 mini. We'll use the same prompt template that they used for the GPT-4, so you can see what that looks like. Just very simple prompt here. Very simple prompt. And then function completions, OpenAI completions, that's probably about right. And then we're just going to change our model name to whatever this is called, which is GPT-4 mini. Cool. Max tokens. The model can take a lot to 128,000, but we'll keep it at 4,096, so it's comparable to the other ones. And let's call it GPT-4.0-mini. That should be that. Cool. Let's just make sure there's no funny business with this. This looks fine. Yeah. Okay, cool. So that's that. So now we have our config file. And I think what we do is just run it. So let's read our help instructions to see how to run this. Okay, took me a couple tries, but I figured out the command for running this, I think. So you can see Alpaca eval, evaluate for model. We do -M10 so that we cap the number of samples that we run that we're evaluating. And that's just because I want to save on, I don't want to spend too much money before I know this is going to work. And then we just pass it the path to our model that we just created. So as it's working, we can start to see what it's doing. So it's giving us a model outputs. So the model we're using is GPT-4.0 mini, which we just set this up. And these are a bunch of test cases. It's running each of those test cases. So here's an example. What are the names of some famous actors that started their careers on Broadway? And here's an output. Many famous actors began their careers on Broadway before transitioning to film and television. Here are some notable examples. And it has a bunch of examples for us. So that's that. And you can see here it's running through. I thought I told it to only run 10 examples. It didn't listen to me for that. Here's another phone run. Write test. Writes the word test. That's great. So these are the generated examples that it's going to use for evaluating the model. And then what it'll do when it finishes, I think, is that we have these reference outputs. So these were generated by GPT-4 1106 preview. And I think and hope that these are not being generated in real time right now, that these are just like previously cached somewhere. So once this is all finished generating, it's going to go through one at a time and it's going to ask GPT-4, hey, which of these responses do you prefer? And then it'll use that to calculate statistics about which model is better. Okay, here we go. So that finished running finally. I had to change my command. I had to more explicitly say max instances equals 10 like this. And so what it did is it ran the, here you can see its evaluation. So GPT-4.0 mini, this is the model we're trying to test out. And you can see here how it compares to all the other models. Now remember, each model is compared to a base model, and in this leaderboard, the base model is GPT-4 1106. So you can see GPT-4 1106 wins against itself 50% of the time, which is roughly what you'd expect. GPT-4 mini, as compared to GPT-4, which is our baseline, wins about 30% of the time. And now keep in mind, which is, well, GPT-4.0 mini wins about 30% of the time, which is comparable to Claude 3 Opus and Claude 3 Sonnet. Now keep in mind here, because I didn't want to spend a bunch of money to evaluate many examples, I only ran 10 examples through instead of 800. So my standard error is much higher, and this could be a much wider range. And so please don't take this data really as an example of how this model compares to anything else. This is just an example of how to run the leaderboards. And you can see here some of the results. So like I was showing before, here are all of our different prompts with outputs that are generated from GPT-4.0 mini. And then you can see our comparisons. So it gave us this whole nice annotations.json file. And here's one of the ones it compared. So how can I make escargot? That was one of the prompts that we got a result from with GPT-4.0 mini, and also had a pre-cached result from our preview model. So then we run a prompt basically asking, hey, which one of these results is preferable? So you ask GPT-4, which output do you prefer? And it has some, it indicates a preference for one of them. I'm not quite sure how to interpret these results. So this is our output data. These are our output annotations, and it can use these to compute the leaderboard comparing all the different models, including the ones we just saw. And just so you can take a look, here's what the prompt looks like to evaluate the results from the different models. So you are a helpful assistant that ranks models by the quality of the answers. I want you to create a leaderboard. Here's the prompt. Here are the output of the models. Now, please rank the models by the quality of their answers. Your response must be a valid Python dictionary. So you can just see what that looks like, what it's using to evaluate. I'm also running it right now on a little more data. So I went ahead and ran the results against the full data set just to see what would happen. So now I've run it against all 800 examples. And you can see here that it actually compares quite favorably with GPT-4 preview. You can see the baseline win rate is 46% versus GPT-4. And then they have this length controlled win rate. Which controls for the length of the response. It turns out that most evaluators, most people asked to compare the results of two prompts will just prefer the longer one, sort of regardless of quality. So they have some algorithm they use to correct for that preference. And after they've corrected for that, GPT-4.0 mini wins 53% of the time. So seems like, comparing favorably to GPT-4. Yeah. Another cool feature I should mention, since we're here, is like you may not be in a situation where you are comparing, a model you just built, because you might not realistically be doing that. But there's some functionality here where you can pass in your own data set. So maybe more realistically for a lot of people than trying to compare different LLM models is you may have data, like you may have instruction pairs that you've already generated somehow, or questions that you're trying to answer, and you might be thinking, hey, if I switch to this new model, if I switch to GPT-4.0, how is that going to affect my outputs? So you can use the same Alpaca tool and pass in your own data set, and then use that to compare models side by side and build a leaderboard that's like relevant for the really specific prompts that you're dealing with. So I'm not going to demonstrate here, but there is a little argument here for an evaluation data set where you can start to pass in your own data.